Example number 4 on combined gas equation. The data given here is at 25 degrees centigrade 760 mm of Hg pressure. Remember children, the pressure is given in 760 mm Hg, which can be converted into atmosphere, or you can stay in this. When the ratios are taken, the units gets cancelled, so we can keep it in 760 mm. We know 1 atmosphere is equal to 760 mm Hg. So this is equivalent to 1 atmosphere originally. So let us keep it aside. A gas occupies 600 ml volume. What will be its pressure? So the question is to find pressure at a height where temperature is 10 degrees centigrade and volume of the gas is 640 ml. So remember children, when the question is given where the same gas is present at two different conditions of experimental conditions, then we have to take the number of moles are equal, from which combined gas equation that comes here will be P1 V1 by T1 is equals to P2 V2 by T2. P1 V1 by T1 is equals to P2 V2 by T2. This will be our formula which you need to proceed further with this, because since the same gas is present at two different conditions, we are going with this particular data. Let us write the data in the next slide and solve this. The given data is P1 is equals to, let us consider this 760 mm Hg. Since it is in ratio, no need to change any unit, keep it aside like that. Where V1 is given as 600 ml at this particular conditions, T1 is given as 25 degrees centigrade added with 273 converts into 298 Kelvin. Always remember Kelvin scale only should be mentioned. Where pressure P2, you can ask, the children will have doubts here, sir, when you are doing the ratio, we are not changing the units of pressure, we are not changing the units of volume, do we need to keep the temperature also in the degree centigrade? It is in ratio only, no? But no, remember, any experimental calculations or mathematical calculation we are doing in chemistry, the units of temperature should be always in absolute scale, not in degree scale. So this is very important, never leave it in degree centigrade, the first point. Now P2, we have to find this value corresponding to the volume 640 ml at new experimental conditions of temperature. T2 is equals to 10 degrees centigrade. Again, this is converted into Kelvin scale as 283 Kelvin. Now this is 283 Kelvin. Now using the formula, I hope everyone remembers the formula which we are using here is P1 V1 by T1 is equals to P2 V2 by T2. P1 V1 by T1 is equals to P2 V2 by T2. I'm using this particular one. From this I can write P2 is equals to, bring everything the other side, P1 V1 by T1 into T2 by V2. I can write T2 by V2. Substitute all the data in this children. 760 into volume is 600 by T1 is 298 into T2 is 283, V2 is 640. So now 1010 gets cancelled. If you solve this particular one, after solving we are getting 676.6 mmHg. So unit of pressure should not change, mmHg. So the pressure, the question they asked you, what will be its pressure at a height? So this is at a height of 676.6 mm mercury. That is the answer we are getting, 676.6. The pressure at which it is measured at 10 degrees centigrade temperature and volume occupying 640 ml. So this is our answer for the question.